Here we go, chapter 11, 11.1, Circumference and Arc Length. Nice to have you along as we walk through this. Our objective is I can find arc lengths and other measures. So our essential question is, how can I find arc lengths and other measures? Arc lengths, what's this thing talking about? Well, let's start with something we know. Circumference is distance around. So go ahead and put that in your notes there. Circumference, just like perimeter is distance around something, so also circumference is the distance around a circle, as you know. And we have two different formulas for circumference. It's either pi times diameter, or it's 2 pi r. And the reason we can say that is because, as you know, the diameter is equal to 2 times the radius. So if we have the diameter, we can just say pi d. If we have the radius, we can say 2 pi r. And you will remember that pi is approximately, see the double squiggles there, approximately 3.4, which is approximately 22.7. So 22.7 is closer to what pi is, but neither one of those, 3.4 or 22 over 7, is exactly pi. So pi here on the calculator, as you'll see, is 3.14, and then a whole bunch of numbers after that. If we were to go 22 divided by 7, that gets us close to what pi was, but not exactly what pi is. Okay, so make sure that you use the pi button on the calculator. Whenever we do this, do not use these estimates, 3.14 or 22 over 7, unless they tell you that it's okay to do that. So we now have an equation to be able to calculate the circumference. So let's get to work. Let's do it. Example number 1 here. They tell us that the circumference of a circle has a radius, or they're wanting us to find the circumference of a circle when we know that the radius is 9 centimeters. So we can use our circumference equals 2 times or 2 pi r, and just plug in 9 for our radius, and so the circumference is 18 pi. So that is the exact circumference, 18 pi, but sometimes they'll ask us to give it to them in a as a decimal. And so if we were to do 18 times, and again, make sure you use pi, the pi button on your calculator, and in this case they are rounding it to the nearest hundredth. Remember, to the left of the decimal point is ones and tens. To the right of the decimal point, this is the tenths, with a th, tenths place, and this is hundredths place. So most likely they rounded it to the nearest hundredths here. Now if they gave us the circumference and wanted us to find the radius, we have to kind of work backwards now. So we can use the same equation, same formula, because we have the circumference and we want to find the radius. So therefore circumference equals 2 pi r. We plug in what we do know. The circumference is 26, and then we have an equation with only one variable. So remember, pi is not a variable, that is a constant, that is a number. So I want to solve this equation now for r, and I would do that by dividing both sides by 2 pi, and so my radius equals 26 over 2 pi, and so that's an exact amount. You could reduce that down to 13 over pi. That would be the exact number. If you wanted a decimal approximation, then you could plug this into your calculator and round it to the nearest hundredth, and you get 4.14 is approximately the radius. Now, here's a question: how would you plug this into your calculator? Do not do 26 divided by 2 times pi. That would give you the wrong answer. So make sure that, as it says here, that you do 26 divided by, and then use your parentheses. That's one way of doing it. Use your open parentheses here. So 26 divided by, then open parentheses, and then 2 times pi, and then close parentheses, and then equal. So let me show you how that works. You're doing 26 and then divided by, tell you what, let me do it wrong first. 26 divided by 2, and then watch when I hit the divided by button, it gives me what 26 divided by 2 is. And so if I was to now hit times pi, it'd be like saying 13 times pi. So in other words, this the pi would actually be up in the numerator, and I don't want that. So that would give me an answer of 40.84 if I was to round that to the nearest hundredth. So that's the wrong answer. Instead, I want to do 26 divided by, now open parentheses, and notice how up in the top right you have these parentheses here, and it goes to 0 because there's nothing inside the parentheses yet. Then I would say 2 times pi, and then close the parentheses. Now that is what is inside of the parentheses, and then hit equal. When I hit equal, that now does the 26 divided by whatever 2 pi is, and that gives me my final answer of 4.138 and following. And as you know, to round it off to the nearest hundredth, I would look to the right. This number is 5 or higher, therefore I add 1 to the hundredths, the number in the hundredths place, and so the answer is approximately 4.14. Another way to do it, if you don't want to use the parentheses, you could also do 26 divided by 2. Oops, I'll do that first. 26 divided by 2, and then now hit divided by again. Divided by, because notice I have my 13. So now divided by pi, and then equals, and that gives me the same answer if rounded to 4.14. Okay, so there's 2 different ways to plug this into the calculator. Be careful though, you do it the one of these 2 correct ways. Example number 2. What they're giving to us here is a tire, and they want us to figure out how far does the tire travel when it makes 15 revolutions. So if you were to start here and then roll this tire, for example, to the left, 1 entire revolution, and then do that 14 more times, a total of 15 times, how far would that tire travel? Well, we do have 15 inches here, but that is your, what they call inside diameter, ID. That's a machinist mate or machinist measurement. ID is inside diameter of the tire. And then, but we want the OD, the outside diameter of the tire. So to get that diameter, I would take 15 and plus 5.5 and plus another 5.5. So I have this entire distance here for the diameter, outside diameter of this tire. So you see here, that's what they do. 15 plus 2 times 5.5, because there's 2 of these 5.5s. So that the entire diameter of the outside of the tire is 26 inches. I can then plug that into my formula of C equals pi times D, and my exact answer is 26 pi. If I was to plug that into my calculator and round it to the nearest hundredth, I'd get 81.68. So the circumference, or the distance around this tire, is 81.68 inches. Which means if I was to mark this place of the tire and then roll it to the left until that point on the tire went up at the top and then came back down, then the distance, the total distance that tire would travel would be 81.68 inches. And they want 15 revolutions, so 15 times it goes around. So therefore I take my 81.68 and I multiply it times 15, and that gives me 1,225.2. I'm not sure why they round to the nearest tenth now, but 0.2 inches. And then we want to convert that to feet, and the way you do that is through this conversion factor of 1 foot equals 12 inches. So we want the inches in the denominator, so that when I multiply it times my original length of inches, it's as if I have a 1 underneath the inches here, and inches divided by, remember fraction bar, think of that as the operation of division. Inches divided by inches cancels out, it's an invisible 1, and I'm left with the units of feet. So I now have converted, so the way I convert 1,225.2 inches into feet is dividing that number by 12, and that gives me 102.1 feet. All right, now it's your turn to do these two guided practice problems here. Here they want us to find the circumference of a circle whose diameter is 5 inches, so you plug in the 5 inches into this equation, and they also want you to find the diameter of a circle whose circumference is 17 feet. So this is a second part of this problem. So you have the circumference, you plug 17 into for circumference, and you want to solve for the diameter by dividing both sides by the diameter. And then here, number 2 is a similar problem to what we had done with example number 2. And they give you a diameter of 28 inches, and how many revolutions does the tire make while traveling 500 feet? So now they give us the distance of 500 feet, and basically how many circumferences can you fit into 500 feet. So go ahead and pause the video and do those two problems, please. Now let's forge on to arc length. What is this arc length all about? Well, an arc length is a proportion, or I'm sorry, a portion of the circumference. So circumference is all the way around. Arc length is just part of the way around. So let me, if I can get a highlighter here. So here is this length here, going from A around this arc to B, is the arc length of arc AB. And you'll remember that this arc here, it can be the measure of degrees. So for example, if this central angle is 80 degrees, then the measure of this arc is also 80 degrees, but notice that's in degrees. But now what we're doing is wanting to find the length. So how do you find the length of this arc here? And in order to do that, you need to know the radius or the diameter of the circle. Okay, so it does depend on the radius of the circle. And the easiest way to do that, to find this arc length, is to use this proportion. And remember, we're accustomed to the basic setup of part over whole, part over whole. So it makes sense, doesn't it, that this part here, the arc length of arc AB, over the entire circumference all the way around the circle is equal to the measure of this arc. In this particular case, it would be 80 degrees in my just example here, over the entire arc, or the entire degrees all the way around the circle, which is 360 degrees. And so here's your proportion, and if you wanted to solve that proportion, you could cross multiply if you wanted to, or if you wanted to solve for just the arc length, you could multiply in order to clear the denominator to get the 2 pi r out of the denominator. You'd multiply both sides by 2 pi r, and that would give you this equation here. This arc length is equal to the measure of the arc over 360 times 2 pi r. And you might want to put in your notes here, just a reminder that 2 pi r, of course, is the circumference. So the arc length, the length of this arc, over the entire circumference is equal to the measure of the arc over the measure of the entire circle, which is 360 degrees. So let's practice that. Here in your book, example number 3, we want to find the measure of this arc AB. So we know that the central angle is 60 degrees, so therefore the measure of the arc is also going to be 60 degrees. And so we can set up our proportion. And we also know that the radius is 8 centimeters. So here's our proportion. Part over whole equals the length of arc B. So we want to figure out the length of that arc AB over the circumference. Circumference is the distance all the way around, so that's the whole, equals the measure of arc AB, here's 60, over 360, which is the whole of the measure around the circle. So if we wanted to solve this for the arc length of arc AB, we could multiply both sides by the circumference to clear the circumference out of the denominator. And the circumference is 2 pi r, and our radius in this particular case is 8. So if we were to then multiply this, or put this into our calculator, you would say 60 divided by 360, and then times 2 times pi times 8. And that would be approximately 8.38 as your answer. So the length of this arc is 8.38. Again, we're using this basic proportion, part over whole. Here for the next one, and to find the arc length of arc EB, or say EF, the central angle is 60 degrees, so the measure of the arc is also going to be 60 degrees. So 60 degrees over 360, that's our part over whole, times, in this case, let's go ahead and jump to, well, let's pretend, let's first start, the length of this arc over the circumference, and we know the circumference is 2 pi r. Your radius in this case is 11 centimeters, so you'd have the circumference here equals the part over whole, 60 degrees over the whole of 360. And then multiply that times the circumference on both sides, or 2 pi times 11, times this. Now, you can think of this as a fraction, is one way to look at it. What fraction of the entire circumference do you want? Well, you only want 60 out of 360. So this is the what fraction of the entire circumference that you want. And in this case, it would be 11.52 if you were to plug that in your calculator. For this example, to find the arc length of arc GH, what fraction of the entire circumference do I want? Well, I only want 120 degrees out of the entire 360. So I want 120 over 360 times, and this is my circumference, this is the whole circumference, which is 2 pi times, and my radius in this case is 11 centimeters. We also have two other examples here where they want us to work backwards. So they want us to find the circumference of this circle. They give us this central angle, 40 degrees, and they also give us the arc length of 4.19. So let's go back to our part over whole ratio here. So I have part over whole. They give me the part of the circumference. The measure of this arc is 4.19. I do not know what the circumference is, so I want to find that. I do know that the part, the measure of this part is 40 degrees, so I can put 40 degrees on top, and I do of course know the whole measure of 360. So that gives me this proportion, 4.9 over c equals 40 over 360. And if what they do here is they first simplify 40 over 360. Remember, we can, if there's two zeros on top of each other, I can cancel out those zeros. So 40 divided by 360 is the same as 4 divided by 36. And there's a common multiple here, 4, so it's as if I'm multiplying top and bottom by 4, or you could even think of it as multiplying top and bottom by 40 if you wanted to. And you would get 1/9. So that's where that 1/9 came from. And then if you wanted to, you could cross multiply. So c times 1, in other words, that's c, equals 9 times 4.19, and that would give me this number of 37.71. So I was able to find the circumference starting with the measure of a central angle and the length of that arc. Pretty cool how I'm able to do that. Over here they give me the radius of the circle, and they also give me the length of this arc, and they want us to find the measure of this central angle, or you could also, as you know, the measure of the central angle is also the measure of this intercepted arc. So let's do our same proportion here. The part over the whole here, the measure or the length of this arc over the length of the entire circumference equals the measure of that same arc over 360. In this case, I know the length of this arc, which is 44 meters, and I also know the radius, and so I can find the circumference. And of course I know the measure all the way around the circle, which is 360. So that gives me this proportion, and probably the easiest way to solve this would be to multiply both sides by 360. And when I do that, on the right side it cancels out, and I'm left with the measure of arc RS. And then plug this into a calculator. So, hey, especially here, if you have a calculator, go ahead and practice plugging this in. So you do 360 times 44, and then divided by, and then what I would do is do a parentheses, open parentheses, 2 times pi times 15.28, and then close parentheses, and then equal. Or if you wanted to, you could say 360 times 44 divided by 2, then divided by pi divided by 15.28, and that would also give you that same answer. So try both of those ways with your calculator and get used to using the calculator for these kinds of computations. Alright, and that is it. You are now ready to jump into your guided practice here, and you should be able to do those problems with no problem. We'll see you soon.